Hello and welcome to another Solana tutorial. This is not how I usually say it, but today I feel like talking in a deep voice for the first 2 sentences because then I'm gonna go back to normal because otherwise I'm gonna get annoyed by my throat aching. Today we're gonna talk about token extensions again. Specifically, we're gonna talk about interest-bearing tokens. There's a bit of misconceptions about this. It's actually super simple, but it might not be so easy to understand, so we just go through it today. Basically, all it does is playing tricks on us and pretends that there's more tokens than there actually are, and that's the whole extension. But that would be too simple if we end the video here, so we're gonna make a 1-hour tutorial video about it. Yeah, so interest-bearing tokens. What do I need to say about that? So you're probably familiar with the kind of use case that we have for those interest-bearing tokens. You might know that from a liquid staking token, where the idea is that the token increases in value over time. Just that we want to also reflect that value increase by having the amount of tokens in your wallet grow. With a liquid staking token, as they are with the old token program, you always have the same amount of tokens, but then they're worth more and more. So for instance, in the beginning, they're worth 1 sol, mapping 1-to-1, and then suddenly the mapping goes down and the liquid staking token is worth more. Therefore, for 1 sol, you don't get a full 1 token anymore, which also means that if you sell the token, you get more sol. That's the whole idea. And with interest-bearing tokens, ideally, we would keep that 1-to-1 matching and just the amount of tokens in your wallet would increase, but it will always stay that 1-to-1 relationship. And there are several use cases why you want to have such an interest-bearing token. In a way, it's a kind of inflation, except you don't really create more tokens, you just make them worth less, but therefore there are more at the same rate. So this might all sound a bit complicated. It's actually really simple. And today we're gonna have a look at that and how we create tokens with the interest-bearing token extension. Now this whole thing might not be as flexible as you might hope it would be. You can just have one rate at which it changes over time. You can change that rate, but still we'll see. We will see how flexible that is. My expectation is that this, yes, is a cool feature for some very specific use cases, but most tokens will probably not use it because it's just not configurable enough. I don't know. Anyway, let's have a look at that today. So, we find ourselves once again in the Solana Docs, the extension guide from Token 2022, where we find the interest-bearing tokens. Let's read through what the docs say. What do the docs say? Ring, ring, ding, 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 ding. Okay, focus. Tokens that constantly grow or decrease in value have many use cases in the real world. Do they? Well, yeah, I mean, liquid staking token and like everything goes up and down. The most well-known example is a bond. Yeah, so you buy the bond and it increases in value without you actually changing how much of the bond you hold. That's the idea. But the cool thing is, I already see in the first sentence, it also says decrease, which means it can also decrease. So we can have a negative interest rate, basically removing tokens. Cool. So with token, this has only been possible through proxy contracts that require regular rebase or update operations. Right, because with the old token program, we didn't have that extension, so we can just have a constant amount of tokens in our wallet. And fun fact, this is still the case, just that this time we're doing UI tricks. So we had to do other things to, increase the token value. With Token 2022 extensions, we have the possibility to change how the UI amount of tokens are represented. So this is just a cosmetic thing, just the UI amount changes. The actual tokens that you hold on chain actually don't change. And that's the one thing that is hard to understand about this one. On chain, we're still dealing with like tokens that are always the same amount, but their UI representation changes over time. So the official token amount changes even though the actual token amount stays constant. Does that make sense? We'll get there. I'll get you to understand this. Don't you worry. So the interest-bearing mint extension, it's an extension on the token mint, and the amount to UI amount instruction. So this, I haven't looked at it yet, but this sounds like we're doing a transaction simulation again to get the UI amount, and we display that instead of the actual token amount. So anyway, with those things, with the extension and that helper instruction, you can set an interest rate on your token and fetch its amount with interest at any time. So why do we need this? Well, because the tokens on chain stay the same, just the display amount changes. So we need to have some way of telling what this amount to be displayed is, and that changes over time without the state changing. So we need this instruction, and we need to call it every time. And that instruction takes into account the time of the cluster, and in the combination of the token account that holds the amount of tokens plus current time, we can calculate, and that's what that instruction does, the amount to be displayed to the user. So the official token amount. Interest is continuously compounded based on the timestamp in the network. Yeah, so timestamp, based on the timestamp. Due to drift that may occur in the network timestamp, the accumulated interest could be lower, and I want to add or higher, than the expected value. Thankfully, this is rare. You know, like outages. Those are rare as well, but they can happen. Remember how Solana was branded the chain that constantly goes down? Yeah, has been a while. Hope it stays like that. And same way with the timestamps. Like in a stable system, it's gonna work just fine. But we did discuss timestamps in this video. Don't remember which one it was, but I'll link it. I think when we talked about sysvars. Note, no new tokens are ever created. So this is the important stuff here. We're not creating new tokens. We're not even changing the amount of tokens in the state. It's just the UI amount returns the amount of tokens plus all interest the tokens have accumulated. And what I'm wondering here is, if I change my interest rate, does that suddenly change the tokens that have been accumulated? But yeah, to reiterate, this feature is entirely cosmetic. So it's just a display thing. On-chain is literally the same as if we wouldn't have that. And you can implement that without having it. You can do kinda interest-bearing tokens without using that extension. Just have to use different ways. But anyway, I want to play around with this extension because maybe it's really, really cool. Average case, it's just another extension that you want to know about, such that you have the big picture of token 2022, and in case one token uses this, you understand what it does and you're not confused as to why the amount changes without any transaction being called on your token account. Because yes, that's the reason why we do it that way, that we don't need to send tokens to the token accounts. I mean, obviously we could do it the, what would that be, the lazy way, the easy and expensive way of literally, you know, every epoch just sending tokens to all token accounts. But that requires transactions to be sent, and that costs transaction fees, and somebody has to send those transactions, and that can't be guaranteed, and whatever. So the simpler way is definitely just to do this UI trick if we have a constant interest rate. And if we have flexible interest rates, then we'll see if we can get that to work as well. This is what I'm here for, figuring it all out. Blah, blah, blah. Okay, so how do we create an interest-bearing token? With the CLI, super easy, just interest rate. And you add the interest rate in, I don't know yet, BPS, whatever BPS is. We can then set the interest rate to update to a different interest rate, so we can have different interest rates. I wonder how it then keeps track of that. I guess I'll have to read some source code today. So this is pretty simple, and we've used the CLI for the past few videos on Token 2022. So today, let's do JavaScript. So today we have a look at that in TypeScript because people requested that I do it without the CLI, but with code. So let's do it with code. And just await a create interest-bearing mint. That is in the Solana SPL token probably. Yeah, let's do this. So we get the Token 2022 program and the create interest-bearing mint from Solana SPL token. And it looks like in my version, it already has that. I did install that package when I set up my computer in that video where I installed all the stuff. So if you're missing that, that's how you get it. Or literally just yearn add Solana SPL token. That's how you would do it if you don't have it, but I do, so I don't need that. We work on DevNet, that seems fine. We created key pair. I want to use a fixed key pair because getting airdrops every time is just not gonna work for me. Grind me a key pair. Who is the guy who sets the interest rate? Central banks. What's the American version of the European Central Bank? Federal Reserve. The Fed. Yeah, it's the Fed. Let's play Fed. Fed 1. So that's my wallet. There we go. Ideally, we then don't need an airdrop because we'll get one here. On devnet, 1 sol should be enough. Come on, we can do this. Yes, we got 1 sol. Nice. Fed is rich. So, obviously, I don't want that to all be random key pairs. I'm gonna once again make myself a helper function. We're gonna move that there. External in a helper function that looks like this. Super simple. Okay, cool. Because now I can create more key pairs and load them. How do we call the mint? Interest bearing mint. IBM. IBM, okay? Yeah, that we take. Mint key pair. And who controls the rate? Well, obviously the Fed. Let's do that. Who pays? The Fed. Who controls the rate? The Fed. Who can freeze? The Fed. Who has the mint authority? Well, obviously also the Fed. Simple. Fed got all the power. Good, the rate 10, I have no idea what that means. Let's leave it at 10 until we figure it out. Decimals, 9 is the default, so 9 it is. And then we create an interest-bearing mint, which needs the connection. We have that. The payer, why do you complain about that? Oh, I forgot to return it. Okay, that's better. Fed is paying, mint authority, freeze authority, rate authority. That's all public keys. That's why we get the public key from the Fed. And the rate and the decimals are just numbers. The mint key pair we provide. And then, oh wait, this thing already creates and sends the transaction for us, right? We don't even need to confirm anything. This thing, oh cool, I already have the implementation here. Yeah, this also does the send and confirm transaction for us with the payer and the key pair, and the key pair, that's the one for the new token, so that will be the IBM okay. If we wouldn't provide that, then it would create a new one. Cool stuff. That's it. That's all. Literally call that function and you're done. I mean, as simple as with CLI, but to change it up, we do TS node and create interest-bearing mint. Let's go. What could possibly go wrong? Ugh, that I didn't even print a signature or anything. That went wrong. What does it return? It returns me the mint? Really? Yeah, it returns me the mint. I mean, good that I know the mint, because it's this. I can now check that on Explorer, if that thing exists. And it does. 222 bytes. It's a good number. And we have that one transaction there, where the Fed paid to create the IBM. The Fed paid to create IBM. Let that sink in. It's the create account, and then on the new token program, that is still an unknown program to the Explorer. We're still early. We have an initialize interest-bearing config instruction with that rate, and then a normal initialize mint on the token program. Now you know it's the token program, but it's literally the same program. Okay, Explorer, you're doing well. Yeah. Mint authority is the Fed. Mint freeze authority is the Fed. Yeah, the logs don't really tell us much, so that just worked. Let's check out that account, and because I'm too lazy to parse it like manually with TypeScript, I'm gonna do it with CLI. You can do SPL token display and then add the token. That will print you some information on that account. It tells us it's a SPL token mint on the new token program. That's the address. There is no supply because we didn't mint any yet, but we are the mint authority, so we can mint some. Sorry, the Fed is the mint authority. And then we see extensions. It's an interest-bearing mint with the current rate at 10 BPS, and the average rate is 10 BPS. Okay, good. Let's mint some tokens. I mean, for minting, it really doesn't make a difference if I do it with CLI. I could just be like SPL token mint that token and mint myself, I don't know, a few tokens. But while we're here creating scripts, might as well. And we're gonna do mint to checked, asserting the token, mint, and decimals. To do docs. The decimals we could query from the token account, or we just remembered that it's 9. And we mint. What does that return? Returns us a transaction signature. Wonderful. And this time we're gonna log it. So let's go through it. Step 1, the connection. I got that. Step 2, the pair. I got that. That's the Fed. Step 3, the mint. We got that. That's the mint key pair public key. Destination. Well, that would be a token account. Where do we mint to actually? Great question. Get or create associated token account. That's the simple way. We just await this again with a connection. The Fed is gonna pay for your token account. The mint. So who's gonna own this? Let's create ourselves a guy who will have some tokens. And who in our example holds token? So who's the guy who we pretend to that he has more money than he actually has? USA. Our receiver. So the owner is the receiver. Puppy. And we allow off curve. Yeah, we don't need that part. Cool. So we await a new ATA. We do get the ATA back, right? Why does it never show what address of the new associated token account? Wonderful. So that's the ATA. The address is what we need here, I think. Then the authority. Well, obviously that's the Fed. Just the public key of the Fed. Then the amount, how many we mint. A bunch. I don't know. And the decimals. Cool. That's it. Oh, and we do need the other token program though. So I should not forget that. I don't need multi-signers, so I can leave that undef. Also don't need that. But I do need the token program. And the same here. I think I forgot that I need to, allow owner off curve. Let's say false, because he should be on curve. But I do want the token 2022 program here. Okay. That's to create, or then in the second round, get the token account of our user. And then we just mint. I mean, as simple as that. A bit more to write than if we were to do it with a CLI, but it's gonna work. I'll show you how that's gonna work. Mint. Let's go. There we go. We got a transaction signature. Isn't that wonderful? How easy that was to create 1 million tokens out of thin air. Bam. Because Fed can do that. Fed can totally do that. Yeah, so what I forgot, of course, to adjust to is to multiply my amount by the decimals, or by 10 to the power of decimals. So I literally just created a milli token, 1,000th of a token. So let's do that again. Adjusting for decimals. There we go. Yeah, that's better. Now we created 1 million tokens. Wonderful. So we have 1 million and a bit. Wait, and the Fed minted that all to the token account of that user? That makes perfect sense. The Fed inflates the USA. The Fed pushes money into USA. That makes perfect sense. So we minted tokens. Great. But now it's time for actually playing around with this extension. See, my assumption is that wallets don't display this, because not even also explorers, I don't think, display this. You display that we have 1 million tokens. That's what you display, even though actually it's 1 million and something. Even if I add my wallet here, you have an unknown token, the IBM, okay, with 1 million, but you don't show me more. This is actually even worse, because I don't see my tokens at all. All right, okay, one more. So there we go. Oh, that looks better. Look at that. Backpack at least really displays the full number of tokens of my interest-bearing mint. Wonderful. But see, I don't think that any of the wallets support the interest-bearing part of this thing yet. Because to them, it's all just what is in the token account, and what is in a token account will just not change. So they will always display that value. So we gotta manually look that up and show the wallets, hey, this is how you do it. Maybe implement that. But yeah, there's a lot of stuff that wallets need to implement for the token 2022. So yeah, let's do check balance with interest. Because this is where it now really gets interesting. Interesting. Get it? We somehow need to get to that UI amount. Now, I have no idea how to call it, but actually, maybe there is something in the Solana SPL token. UI amount to amount. Oh, there is something. Oh, yes, there is stuff. Nice. I thought I would need to read source code and see how that instruction can be called, but I don't need to. But I also want to. So let's do that. Before we just do that, we do want to see how it is actually implemented. So GitHub, here we come to the Solana Labs SPL token program 22 source extension. interest-bearing mint. Now we have an instruction here. Is that big enough? Should I make it a bit bigger for you? We have the initialize, we have the update rate. That's the actual instructions that actually do something. But then where is the thing with the UI amount? There we have some timestamps. 1 in basis points. Annual interest rate expressed as basis points. Probably BPS stands for basis points then, and not base per second. So what's stored in the interest-bearing config? The authority, the timestamp of initialization, then average rate from initialization until the last time it was updated. Okay, so it stores every time we update the pre-update average. Okay, that, I mean, complicated, but cool. And then the last update timestamp and the current rate. So let's analyze this. Assuming there have not been any updates, with the initialization timestamp and the current rate, we can calculate the current amount because we have the time when it started and we have a constant amount, like the constant rate until the current time, and that current rate is in there. And we can go from initialization timestamp to the current rate. Now, when there is an update and we now suddenly change, going in the wrong direction, right back in time from left to right, whatever. If we now change, then we take that time and the average rate. So in this case, it's the current rate. That's the average rate. And we make that point and we save the timestamp. Okay. And now going forward, I'm still pointing backwards. We have a different rate. And then we make a point in time again, and that time we actually need to calculate the average rate of the previous time because we now need to average this rate plus this rate. And with the average, we can, calculate as if it was at the same rate, even though it might have gone like this, but with the average, it went like this, comes to the same value because we always have just intervals with constant rate. There is no, but you can make many points and change the average a lot. So actually it is quite flexible. Yeah, and with that average plus the current rate, we can at any point calculate the total interest, so the UI amount, because we have that average to that point and then again that part as if we started here and already had some interest, right? So, okay, that's how it works behind the scenes. Cool. At least that's what I imagine because I see these and I could totally read source code to understand it. There it is, the amount to UI amount, which is a function. So maybe that's not even an instruction, but it's literally just a function. I mean, yeah, we don't need to run it through the cluster. I mean, we do need to run it through the cluster because we need the cluster time. But if we have the Unix timestamp, yeah, if we have the amount, the decimals, and the Unix timestamp, then we can create the scaled amount, is how they call it. Scaled amount with interest, or UI amount, with how many we have times a total scale based on decimals and the timestamp, and the total scale is pre-update exponent times post-update exponent. So post, so it's just the timestamp minus last timestamp, and then the pre-update, that was pre-update average rate times the pre-update timestamp, which is the last update minus the initialization. Yeah, cool. That confirms all of my assumptions that I had from reading this, and it's just the implementation. So we have that difference multiplied with the pre-update rate, and then we have that difference, so the current time difference to the last update multiplied with the current rate. Cool. And both of that together with 10 to the power of decimals, as we also did here, that will give me the result for the total scale, which is what the amount to UI amount returns as a string. Okay, cool. Yeah, I mean, simple. That's not even an instruction, that's just a function. Try to convert the UI representation of a token to its raw amount. That's the other way around then. We have the scaled amount and we divide by the scale. So when we create the UI amount, we multiply with the scale, and then the reverse is of course to divide by the scale. Makes sense. And we're dealing with floating points here, so of course it can be a little off, but it can always be a little off with the timestamp. So we're not working with exact values here. That's the thing. At the token side, so on the state of Solana, like in the token accounts, we of course work with U64s, like integer values, not floating points. But for this UI amount, we can work with floating points. There might be rounding errors, but here we don't care. But when you send tokens around, you don't want rounding errors. You want that to be precise, obviously. Yeah, so we then do some checks if that can be, and if it is, then we just round it to a U64. So yeah, that's the reverse. What else do we hear? That's how you calculate the time-weighted average rate, and it probably does exactly the thing that I imagined that it does. So we have the pre-rate and the current rate, and then subtract the timestamps, and then we add those timestamps together, and then the average rate. If we only had that, if we didn't have a previous rate, then it's the second rate, obviously, and if we had one, that we multiply that with the first timestamp, and we add that second rate with the second timestamp, and then we divide by the total. So yeah, it's an average. You build an average. Congratulations. So it does the thing that I expected to do. Great. What else? We have some tests. Yeah, okay, cool. So we looked at that on chain as well. I'm happy with that. On chain, in the source code, I mean. Let's actually use it. So all I want is just the UI amount. No, that's the wrong way around, but we might do that later. Amount to UI amount. That's what I want. What do you need? You are async, so await. You return a transaction error. Well, but that lets me think that we do simulate or call a transaction. What does that do? Let's look at it. I like that I have the source code. I love it. So we do create a transaction, create amount to UI amount instruction. So there is an instruction that does that. And then we do simulate that transaction. So I was right in the beginning. But here it doesn't look like this is an instruction. Processor, process update rate, process instruction, decode instruction type, interest bearing mint, initialize or update rate. Here again, I don't see it. But yeah, whatever. In any case, we do a simulate transaction, and the return data contains, I think I want to look at that myself. But first, let's do it the simple way. Let's leave the stuff abstracted away. We need a connection and the mint. And then we can say, with that connection, the Fed is gonna pay for that. Actually, can I just have a new key pair here, because nobody's paying here anyway. The mint, the amount. Yeah, so I could query the amount from the token account, or I just say, well, let's pretend I had 1,000 and just see what happens. And anything else I need? The program ID, well, cool. All right, let's see if this works. Check my balance, please. Well, you know what? Maybe I should also print that. Account not found. You're talking about my key pair? Can you not simulate that transaction because I don't have funds on the key? Okay, fine. Let's get the Fed. There we go. Whoa. That's an interesting amount now, though. Why from 1,000 token? Oh, hold on. 1,000 again. I forgot to take decimals into account if I again added the decimals. So with multiplying the decimals, then I would be at 1,000 tokens, right? That's the tokens, and that's the interest that occurred. Nice. So that looks cool though. So yeah, from 1,000 tokens, I would have at the current rate already like 93 micro tokens in interest. That's cool. And if we then convert it back, how did they call it on chain? So that was the scaled amount. Yeah, amount and scaled amount. Unscaled. That's the opposite of scaled, right? Await UI amount to amount with the same connection pair mint. That's the UI amount now. And then token program. Null is not assignable to string. Okay. If UI amount. Transaction error is not assignable to string. Wait, hold on. You return me a string, a transaction error, or null. Okay. Okay. Let's learn TypeScript. Like this. Okay, that's weird. I mean, that just looks ugly, but okay, if we get that back, and we know that we get that back, then we can scale it back. And the scaling back actually does not result in any rounding errors, so we get the same as we started with. And again, this is without taking decimals into account, so you have to ignore 9 zeros here. But yeah, we already see that now we have 100 micro tokens. So this is going somewhere. And if I do it again, then it's not 4 but 5, no 6 even. Nice. We see that the UI amount is changing, even though on state nothing changes. This is all just UI tricks. We all just pretend that we have more tokens than we actually have. So let's freeze the interest rate. Let's play Fed and set the interest rate to 0. Because that's what Fed does. Messing with interest rates. Update interest rate. Update rate for interest-bearing mint. Yeah, that's the one. Or before that, I actually wanted to look at the transaction simulation to see what is actually being returned here, because that could also be super useful. Because we are simulating a transaction, I do want to analyze that some more, because that's fun. And it's probably the same in the other way around. That probably also does a simulate transaction with the same thing, yes. But here we do a U64 decode from that data. So here we get a U64. You know what? I'm gonna borrow that function for a second. I'm gonna put that here. My amount to UI. And that we again import from SPL token, which builds us this instruction where we encode as a big int the amount. That's it. So it's just a instruction specifier and the actual amount. Encode that into the data, and then we send it with those keys. Well, actually, we create the transaction instruction with that. So it's literally just a big int amount. And all I want to be able to do is print that return data, because I want to see what's there. So, oh, that's base 64 that we get returned. Oh, and buffer from takes the 0 and 1. So takes the 0, that's the data, and the 1, that's the format, base 64. This is the encoding, and this is the data. Oh, well, yeah, that makes sense. Okay. Yeah. Okay. So we see we're getting back, as we saw in the transaction simulations video, we're getting back base 64 encoded return data that we can then convert back. And that, I think, is the string, this one. Okay, cool. Now we also saw that. And then the other way around, it's similar, except we now, what we are returning is a U64. So yeah, and here we decode that from the buffer into a U64 again. Okay. And the UI amount is actually a string that is returned. Okay. Okay. All good. I built an understanding. I'm good. Cool. Let's do the next thing. Now that we did that, and we have 1, 2, 3 micro tokens. Let's do the thing with the freezing interest rates. Let's go. Update rate interest bearing mint. My new rate is 0. We're gonna update rate interest bearing mint. Connection. Fed will be signing the mint. The rate authority is again the Fed. So Fed pub key. The new rate, and then we don't need that, and we don't need that, but we do need the token program. Okay, what do we get back from this? A string, so probably the, yeah, create update rate interest bearing mint instruction is what's behind this. Again, it's just creating the instruction, puts it in a transaction, and sends and confirm it. Actually, you can also work with this directly if you want to build a transaction that contains more instructions. You want to get those out, but I'm in this video just using those wrappers because they make it easy. Like, they make it super simple. Oh, the rate also needs to be a signer? Okay. The rate authority also needs to be a signer. That's fine. Cool. And let's log my signature. By the way, that's how the entire thing looks like. There we go. Clean screen. Thank you. That's how that looks like. super simple. We just call that with, the Fed being the payer and the rate authority, and we define a new rate. So let's check once again the balance, and then directly after we update our interest rate. That worked. And now we check the balance again. We're now at 130 micro tokens. And that should now not change anymore because my current interest rate is 0. That's now always the same. I mean, I don't expect that we're going to see many interesting things in this transaction. It's probably just a call to an unknown program with an unknown instruction. Yeah, unknown program, unknown instruction. How do you not know that program? I'm signing twice because I'm the Fed. Update interest bearing config rate. That's all we do. And we update it. New rate is 0. So now we're at 0. Still didn't change. Yeah. But while we're here, let's try something. Can I have a negative interest rate? Minus 100. We're going completely insane. We're paying people now to hold money. No, wait. People need to pay us now to hold money. So holding that token loses you tokens. Except it doesn't really because you hold the same amount, but the UI amount changes. So the perceived amounts change. Let's do that update. Went through, and now when we check the balances again, we can slowly see them go down. Isn't that fun? It's going down. I'm yelling timber. Nice. So we can also have a negative interest rate. That does work. But what is the maximum interest rate that we can set? Because we can go completely insane. Can we go minus 100,000? Nope. Error out of range. Cool. The value of value is out of range. It must be between 32,000 and minus 32,000. Where do those values come from? There is no validation on the rate, since ridiculous values are technically possible. Well, but where does that limit come from then? Ridiculous values are technically possible, say the docs. Well, say the docs in the source code. I want to do ridiculous values, please. I don't see where that check is coming from. Okay, maybe we're failing somewhere else. It's not the on-chain that we're failing at. Generator next. The generator can't put rates because the rate, what's the format of the rate? Basis points. And basis points, we had that was a pod I16, assigned 16-bit value, aka 2 to the power of 15 minus 1. 32,767. 32,767. Yeah. And minus 32,768. Okay, so those limitations are by the data, how do you call that? By the data type, because it's a signed integer with only 16 bits. So only 2 bytes we have for that rate. Okay, well, I mean, so from talking so long, let's check. By now we're probably below our 1,000. Nice. Let's go even more crazy with the largest that we can go, or actually the lowest that we can go, the largest that we can make it go down. Now we should see our tokens fade away. We're dealing in seconds here, right? But hey, we already see some stuff, some rounding errors here. There were some rounding errors. Did you see that in the lower parts? So I mean, still 1,000, but here with the timestamp and stuff, it was a bit off. And we can see how our tokens get less and less. That's funny. At that rate, the time difference of checking this amount to converting it back with the same amount, here the time difference of that one transaction simulation and the execution of that code is enough to mess with the result a bit. That's funny. Sometimes, at least. And always the same value because ticks and stuff. But yeah, our tokens are fading away. Even though we still have 1,000, actually, this is just an arbitrary example. We don't actually have that. What we do here have is 1 million somewhere in the token account. But here the explorers, they don't mind. They will always display me this. Backpack will also always display me this. Phantom will also keep pretending I still have 1 million because they didn't implement the UI amount yet. They will probably. Explorers might even do two separate things, like the actual balance and the UI amount, or the actual balance and then in brackets the UI amount. That's what I would expect from a good explorer. So yeah, explorers and wallets, all those extensions. I mean, I know the wallet, you have so much to do. I don't want to tell you what to do, but eventually you want to support that. Latest when Token 2022 actually comes out as token extensions. Yeah, so that seems to work. We can have a negative interest rate and steal all the people's money for holding their money. Let's do positive interest rates again. Positive maximum value and update to that such that it starts increasing again. So now we're at 9.7 and we will slowly go up now. And I would expect that at some point we might get tokens less than 1 million. Yeah, that's what I expected, because now we go in the other way and the time difference then takes it the other way, of course. So now we have fewer tokens when we check the balance and convert it back from the scaled to the amount. That's pretty fun. So now we can wait for that amount, the UI amount, to increase again. And that's the fastest rate that we can increase it by, which is a ridiculous amount according to Docs. And what is that actually? So the basis points, how do they get in there? That's the amount of basis points that we would get per year. We have 4 decimals for basis points. So basis points in that case is hundredths of percent. Basis points, as you know, basis points from, stock trading, because 100 basis points is 1%. That makes sense, yes. Then we have seconds per year. That's just the multiplication. Yes, that makes sense as well. And then from the Unix timestamps, we get the seconds. And how is that rate calculated now? We divide by basis points and seconds per year. So that would mean in my current setup, I have 32,700 basis points per year. So that means in a year, my token would gain 3x, right? Approximately. Let's calculate the percent per second. So every second I would get 0.001 basis points, which means there are that many seconds per year. If I could set my new rate to this, then I would get 1 basis point per second. This is the largest that I can do. Now I get a 10,000th of a basis point per second, which means if I have 10 to the power of 8 in the amount, then I should get 1 token per second now. Let's see. That could actually work. 2, 3. I'm counting seconds too slow. How fast are seconds? Give me a time. Oh, here I see seconds. 3, 4, 5, 6, 7. Let's check. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Nice. That works. We now get 1 per second. Cool. So we figured it out. The rate is in basis points per year. So this is, and the 8 comes from those 4 plus those 4. So if I could set it to that number without the dot, then I would have 1 basis point per second. This would be 10,000 basis points per second, which means 1 per second, which means for 1 token, I get 1 token per second at that rate. So that means at that rate, I get only a basis point per second. And at that rate, I only get a 10,000th of a basis point per second. But now bringing it back to the year, so if I have 1, then that's 1 basis point per year. So my in basis points per year was correct. But good that we discussed that as well. So I could set it to 1 and then I get 1 basis point per year. A realistic value for the Fed to set it to, what's the current interest rate? In November is 5.5%. 5.5% in basis points is this. So this would be an interest rate that matches the US dollar at the moment. So if we set that, then we get 1.710 to the minus 9 basis points per second. That's not basis points per second anymore, is it? This is wrong. Multiples per second. If I have 1 basis points per second, then I shouldn't divide through basis points. That's my naming issue that I had. Okay, we currently get 0.000017 basis points per second. But that's a ridiculous value, but also per second is ridiculous. So per year makes more sense. At 5.5% per year, it looks like this. You can check your balance. Let's say you're just a millionaire. So we're a millionaire, we check our balance. We already got some interest when interest rates were crazy high earlier. But now we have $1,081.98. And we wait a bit and we have 82 because we're paid interest in 5.5%. Because we are the one getting the interest. In reality, it still works the other way around, where we would need to set negative, where not we get the money. So this is not at our bank account where we get 5.5%. At which bank account do you get 5.5%? In reality, it looks more like negative 5.5%. So you can check your balance. You're a millionaire. But then basically, you could watch your money go down in real time. I mean, it's not like crazy much, but it is a few cents every few seconds. And that's crazy when you think about it, because that's the real interest rates. If you're a millionaire, which I know most of you are, but you can see like you're losing money like with every second, like it goes down, it goes down. It's so crazy to observe that, because that's the real interest rate and people don't think about that. But that's what happens to all our money, except that we don't see it because the money stays the same, right? The money on our bank account, it stays the same, but the value of it just keeps going down without us actually noticing it. And with those interest-bearing tokens, we can make that more obvious to the user by pretending that they have different amounts of tokens than they actually have stored in the state. And that, ladies and gentlemen, is interest-bearing tokens, the interest-bearing token extension of Token 2022 for you. Yeah, I want to stop this because this is how fast we lose money. Oh man, enough of that. Set my interest rate to 0 again. That was fun, wasn't it? Learning about interest rates and interest-bearing tokens. I hope that you understand now how this UI trick works by just showing the user some amount that is not actually the amount that it has in the token account, but that is calculated based on the amount on the token account and all of the previous rate changes. And that's actually more flexible than I thought in the beginning, because we can change the rate as many times as we want and thereby creating our curve that we want. We can set the interest rate like the Fed every few weeks or a few days or a few seconds on Solana, because on Solana things happen quicker. So we can, every few seconds you can update your rate. And the cool thing is, on chain, we don't need to keep track of every single rate change. We just need to keep track of the average overall, which, is the same. Because if you have something like that, it's the same as having that to calculate the values starting from here, right? Mathematics. So actually that's quite cool. And I can see how people are going to use this token extension to create tokens that look like they're getting more and more. They accrue value in their wallet, even though no actual tokens are touched. And it's just kind of inflating and putting to the user, so basically you're inflating and giving stimulus checks in the same height at the same time, right? That's what the Fed does. Except it creates way more money than it gives to the user. Yeah, that's my video on the interest-bearing tokens. Here are some other videos. Here's a full playlist on Token 2022 stuff and a video that YouTube recommends. Make sure you subscribe, like this video, and I will see you in the next one. Till then, bye-bye. And let me know which token extension we're still missing that you want me to check out. There are still a few left. And there are new ones coming, like soon our metadata will get to have collections as well. Like there will be groupings of tokens. That's gonna be cool. I'm looking forward to that. But there's no documentation on that yet. But I already saw a commit by Joe. So I'm not gonna run out of video ideas. And I'll see you in the next one.